Good morning to everyone. My name is Venkateshwar Rao, lecturer in computer science from Government Polytechnic for Women, Pepe, and the subject is programming in C. And today topic is problem solving steps and algorithm and then program. See the objectives for today is, and today we are going to start the first unit of this subject is programming methodology and introduction to C language. Okay, and today objectives are the steps involved in problem solving. It's the first objective, and the second one is some definitions regarding algorithm and its characteristics, and definition of the program. See, if you see, the problem solving with the computer involves the following steps. See, to solve a problem, okay, it has some steps to be done. The first step is problem definition, and the second step is analysis of the problem. The third one is algorithm, okay, defining algorithm, and the fourth step is designing the flow chart, and the fifth one is designing the pseudocode, and the sixth one is coding, and the seventh is running the program, and eighth one is debugging, ninth one is testing, and then documentation. All these are the steps involved in solving the problem. Okay, first we see problem definition. Okay, problem definition. See, this is the first step in computer problem solving. This problem definition is the first step, okay, to solve a problem. Okay, the problem solver should understand the problem thoroughly in terms of the requirements. Okay, the person, okay, who is going to design or who is going to solve the problem has a thorough knowledge of the problem. What is the problem? That should be known to the solver, or we call him as a programmer. That is, what are the inputs and outputs? So for a program, what are the inputs that are needed and what output the problem will give? Okay, that should be thoroughly known to the problem solver or the programmer. Here the programmer should extract from the problem statement, okay, a set of well-defined and precise tasks that can be carried out. Okay, here he has to write down, or he has to define the statements regarding the problem. Okay, and if the problem is not properly interpreted, then we cannot obtain the desired result. See, if that problem is not properly defined, the problem is not properly interpreted, then okay, the desired result, we cannot obtain the desired result, or it may give the error results. Okay, so this is the first step to solve a problem. Okay, here the programmer has to has the thorough knowledge of the requirement. See what inputs the program takes and what output we are going to expect from that program. That is to be known to the programmer. That is the first step to solve a problem. And second step is analysis. The second step is analysis. So the given problem must be analyzed before it is solved. So before going to solve the problem, okay, we have to analyze it. We have to analyze the problem. See, this determines the data items, their types and relationships. So what data items your program needs? It needs integers, or it needs float numbers, or it needs characters that are to be determined. That are to be determined. And we should specify the operations. So what operations your problem will have, or it is having arithmetic operations, or it is having the logical operations, or it is having the relational operators. Okay, all these operators are to be specified. Okay, to be performed on them and check the suitable in terms of memory execution time. So we have to keep in mind that while defining the variables or while defining the data items, we have the knowledge of the size of the variables and how much the variable occupies the memory in the system. Okay, that is analysis phase. Okay, I'm going to the third phase, is algorithm. See, algorithm is nothing but it is a step-by-step process, or we call it as a solution for a given problem. See, these are nothing but these are the steps, or we call them as the step-by-step process. Okay, that is the algorithm. Okay, and the fourth step is flowchart. Okay, so flowchart is nothing but the pictorial representation of the algorithm. So algorithm is a step-by-step process, and for this step-by-step process, the flowchart is the pictorial, or we call it as a diagrammatic representation. The diagrammatic representation or pictorial representation of algorithm is called flowchart. That is the fourth step. When it comes to pseudocode, so here the pseudocode is neither an algorithm nor a program. It is not an algorithm or it is not a program. So it is an abstract form. Pseudocode is an abstract form of a program. It will not give the detailed information. Abstract means it will not give the detailed information of the program. That is the meaning of abstract. And it consists of an English-like statements. Since pseudocode, okay, we use the statements which are look like English language and which perform the specific operations. These statements will perform the specific operations. Individual statements will perform the specific operations. Okay, and it is defined for an algorithm. So for algorithm, we write the pseudocode. Write the pseudocode for the algorithm. And it does not use any graphical representation. So in algorithm or in pseudocode, we will not use any graphical representations. We use the English-like statements. In a pseudocode, the program is represented in terms of words and phrases. So here we use the words, English-like words and phrases. But the syntax of a program is not strictly followed. Okay, see there is no syntax for the pseudocode. Okay, like program will have some that is we call it as a syntax, whereas pseudocode it does not have any syntax. It just has the English statements or phrases or words. And next advantages. Let me see the advantages of the pseudocode. Okay, so here pseudocodes are easy to read. You can easily read the pseudocodes and easily understand them. We can easily understand the pseudocodes and we can also easily modify it. That we are the advantages. We can easily read and we can easily understand and we can easily modify the pseudocodes. The program can be developed easily from a pseudocode rather than a flowchart. So if you have a pseudocode, then it is easy to design the, or it is easy to develop the program by considering the pseudocode rather than the flowchart. So this is the pseudocode. So let me see one simple pseudocode to perform the basic arithmetic operations. So arithmetic operations are nothing but addition, subtraction, multiplication, and division. Okay, these are the arithmetic operations. So for that, this is the pseudocode. See, these are nothing but these are English-like languages. The statements are in like English languages. So here we have written as read n1 comma n2. Okay, so these are the first statement for the pseudocode. Read n1 comma n2. These are two numbers. N1 is one number and n2 is another number. On this n1 and n2 we are going to perform the operations. That is arithmetic operations. So here sum is about n1 plus n2. See, n1 is one number and n2 is another number. We are performing the addition operation and we given the name it as a sum. We given the name it as sum. And in the third step, okay, differentiate. Okay, that is called n1 minus n2. See, this will give the difference of n1 and n2. That is subtraction operation. We call it as a subtraction. This will perform the addition and this will perform the subtraction. When it comes to this fourth statement here, multiplication, MULT. This multiplication is called n1 into n2. See, between the n1 and n2, okay, it is going to perform the multiplication operation, okay, and that value is in this variable MULT. And next, since we have performed the division operation, division gives the quotient. Okay, see n1 by n2, it is performed the division operation and the result is stored in QUOT. And here in this step, we are just printing the values. Here we read the values n1 and n2, and finally we are printing the sum, difference, multiplication, and quotient for these output values. Sum is one output value, difference is one output value, and MULT is one output value, and QUOT is one output value. All these values are printed on the screen, and this is the end. So this is called a pseudocode. This is like a English-like languages. Here we use just words. Read is a word, sum is a word, differentiate is a word, multiplication is a word, print is a word, quotient is a word, end is a word. All these are the words. So this is the example for the pseudocode. And the sixth step is coding. Sixth step is coding. So here the complete structure of the problem to be solved by the computer is called a program. See, program is nothing but it is a complete structure of the problem. Okay, that is called program. And the computer does not process an algorithm or a flowchart but executes the program. See, computer does not understand the algorithm, it will not understand the flowchart, but it understands the program and it executes the program. The program steps are understood by the computer. It will not understand algorithm or flowchart. So, program is a set of instructions to solve a particular problem by the computer, and the actual process of writing a program is called coding. So, here the program is nothing but it is a set of instructions. Program includes a set of instructions. Okay, instruction is nothing but one individual statement is called instruction. Okay, and writing this program is nothing but it is called coding. Coding is nothing but writing a program is called coding. And next, programs are written using programming languages and are fed to the computer. So, programs are generally written in programming languages and then these are forwarded to the computer. Okay, to generate the output. Program involves the instructions and writing the program is called coding. Okay, after writing the program, You just give the statements to the computer and the computer will use the outputs. Okay, that is called the sixth phase coding. And the seventh phase is running the program. In sixth phase, we just written the program, and in seventh phase, we have to run the program. Okay, so running the program is nothing but executing the program. Okay, executing the program in CPU is called running the program. This phase of problem solving with the computer involves 3 steps. So here the running program involves 3 steps. The first step is understand the instructions. In the first step, you have to understand the instructions. What instructions do your program is having? That is the understand the instruction first. And then store the data and instructions. You can store the data and instructions. Understand it, store it, and perform computation. Perform computation. These are the 3 steps. Okay, involved in problem solving by the computer. The user prepares a program and makes it ready for execution. Generally, the programmer or the user will prepare or write the program, okay, which is ready for execution. All instructions stored in the RAM must be fetched one by one by the ALU, Arithmetical Logical Unit, to perform corresponding operations. Program is written and the program is to be fetched. Okay, that is one by one instructions are to be fetched by the ALU and then the corresponding operations are to be performed. So this is called the fetch and execute cycle. So this step is called fetch and execute cycle. And the process data is stored again in the RAM. So after performing the operations on the instructions, again the data is again stored back to the RAM. And finally, they are transferred to the output devices. Finally, the result that is generated by the program is transferred or displayed on the output devices. Generally, output devices are monitor screens. Okay, that is running the program. The 7th step. In 8th step, that is the debugging. 8th step is debugging. So the process of detecting and correcting error in the program is called debugging. So bug is an error. So in simple terms, bug is an error and debugging is the process of detecting and correcting the errors. Okay, errors are common in the program. Bug is nothing but error, and finding the error and correcting the error is called debugging. And there is a problem. There is a program called debugger that takes object program as input and execute it and helps in eliminating the mistakes that occurred in the source program. See, the debugger, generally the debugger will performs the debugging operation. See, debugger is nothing but again it is a program, okay, which finds or which detects the errors or mistakes in your program. It is called debugger. Debugger performs debugging operation. See, the term debug was coined after detecting a real bug in Mark, an electronic machine computer. So initially, Mark computer, they found the error, okay, and they name it as a bug in the year 1945. Okay, it is about debugging. In 9th step, it is a testing. See, the process of executing the program to test the correctness. So testing is nothing but here we test the code whether it is correct or not, whether output is correct or not. That is called testing. Okay, and executing with different set of data. Test the program. So here what we give is, here we perform or here we give different values and we test the output, whether the output is correct or not, whether the output getting your correct or not. And logical errors are the outcome of this process. Sometimes it will give the logical errors. Okay, so when you are testing with some input values, if your result is not correct, then then there arises the logical errors. Okay, that is the testing phase. And the last phase is documentation. The last phase is documentation. See here, while writing program, it is a good programming practice to make a brief explanatory note. Okay, so here the documentation includes a brief line, or we call it as a brief statement. Okay, which explains about the program steps, or it explains about the program, or it explains about the programming steps, or it also explains the segments, program segments. Okay, that is called documentation. So documentation is nothing but a brief explanatory note is called documentation. So this explanatory note is called comment. Sometimes it is also called comment. Okay, it explains how a program works and how to interact with it. So this comment will says the user, okay, and it explains what the step is going to do, what the step will do. It explains what the step will do, or what the program segment will do. Thus, it helps other programmers to understand the program. So this is, the comments are useful for the programmers who are not involving in that particular program. Okay, that is the use of the comment. See, all these are the different steps that are involved in the problem solving. Okay, the first one is the problem definition, second one is the analysis phase, third one is the defining the algorithm, and fourth one is the designing the flowchart, and fifth one is the designing the studio code. Okay, and sixth is the coding the program, and seventh one is the running the program, and eighth one is the debugging the program, and testing the program, and documentation. So all these are the 10 steps to solve a problem. Okay, and next we see some definition. It is algorithm. Okay, and we also see the characteristics of the algorithm. First we see what is the algorithm. See, algorithm is the problem solving technique. So before you are going to solve the program, first you have to design the algorithm. This is the problem solving technique. Algorithm is the problem solving technique, and it can be defined as a step-by-step process to solve a particular problem. Okay, that is the definition for the algorithm. Algorithm is nothing but step-by-step procedure or process to solve a particular problem. It is a step-by-step instructions called as a step-by-step statements. Here it consists of English-like statements. Algorithm also it consists English-like statements. Here we use the statements or phrases which are in the language English. Each statement must be precise and well defined. The steps should be precise and also those are well defined to perform a specific operations. Okay, and when these statements are carried out for a given set of conditions, they will produce the required results. Okay, see, if the statements are arranged in a particular manner, then it will use the desired results or required results. Okay, this is the algorithm. Next we see some characteristics of the algorithm. Okay, the first characteristic is input. Okay, so input nothing but the program may accept 0 inputs or more inputs. Generally the program will take zero inputs or more than what inputs. That is the first characteristics of a algorithm. The second one is output. See, algorithm, it should produce at least one. Okay, algorithm should generate one output. It may take zero inputs or more than one inputs, but in case of output, it should give at least one output, or we call it as a result. At least it should give one result. That is the second characteristic. And third one is the definiteness. Okay, so each instruction must be clear. Definiteness is nothing but it should clear and it is well defined and it is precise. That is called as definiteness. It should be clear, well defined and precise. Okay, that is the meaning of definiteness. There should not be any ambiguity. Okay, there should not be any ambiguity. That is called definiteness. Okay. No ambiguity is same as that is equal to clear, that is equal to well defined, that is equal to precise. And the fourth characteristic is finiteness. Okay, finiteness of the word, it should be a sequence of finite instructions. The instruction should be in a finite number. It should be in finite number. Finite means less. The instruction should be in less number. That is, it should end after a fixed time. It means after a fixed time or after a fixed steps, it should end. And it should not enter an infinite loop. Okay, your algorithm should not enter an infinite loop or there should not be more steps or more instructions. That is the meaning of finiteness. That is the fourth characteristic. And the fifth one is effectiveness. The fifth characteristic is effectiveness. So this means operations must be simple and carried out in a finite time at once or more levels of complexity. So effectiveness includes it should be simple and it should carry out a finite that is the time at one or more level of complexity. And it should be effective whenever traced manually or the result. See, it should give the effective result, no ambiguity. There should not be no ambiguity in the result. It should give the effective output or effective result. Okay, that is called effectiveness. All these are the 5 characteristics of a algorithm. Okay, next we see about program. Okay. Here, the program is nothing but it is a set of instructions. Program is a set of instructions that those are written to carry out a particular task. Okay, the definition already we have seen in the coding. Okay, we have seen already in the coding. Yeah. Okay. So here the coding is nothing but the process of writing the program is called coding. This is the definition for the coding which is discussed previously. Now we will discuss clearly about what is our program. See, program is a set of instructions written to carry out a particular task. Your program should perform a particular task. See, here the particular task is nothing but if your problem is addition, okay, then your program should perform the addition of that. If your problem is subtraction, your problem must perform your problem must have the instructions which are related to the subtraction. Okay, that is called particular task. The particular task nothing but particular operation. Okay, and the terms computer program, software program, application program, system software are just programs that are used to refer either an executable program or the collection of source code from which an executable program is created. See, all are nothing but different programs. software programs, computer programs, application programs, system softwares. Okay, all these are nothing but the programs. A computer program is a set of instructions or statements to carry out a particular task by the computer CPU. So the CPU will perform the tasks, or it performs operations or tasks on the program. And using set of instructions or statements, the user can develop a program or software which is called program. Okay, so the development of the program is called programming. The development of the program is called programming. And here the program tells the computer that the system will do what the system will do. Okay, the program tells the computer what the system will do. So program involves the instructions or steps. Each and step will perform some separate operations. Okay, this tells the computer what the system will do. And specifically, the term software describes an operating system or application. Okay, software nothing but it can be the operating system or it can be the application software. The computer takes instructions in the form of computer programs. So generally the computer takes the instructions from the user in the form of programs and carry out the requested task. It performs the operations or it performs the tasks. The human beings cannot interact directly with the computer using natural languages. Okay, see, like the languages which we use in general life, okay, those are not suitable for the computers. The human being languages are not suitable for the computers. Okay, because the computer knows the and understand only the programming languages. It only understands the programming languages. It will not understand or it will not deal with the natural languages which the human beings use. It only understands the programming languages. And there are different types of programming languages out there. It is a BASIC, COBOL, Fortran, Pascal, C, C++, Java, .NET. Okay, all these are the different programming languages. All these are nothing but we call them as the different programming languages. So here we discuss about the algorithm. So algorithm is nothing but the problem solving technique. An algorithm is a problem solving technique, and the definition of the algorithm is it is a step-by-step procedure to solve a particular problem. To solve a particular problem, it is a step-by-step procedure. Here the algorithm consists of English-like statements. Here we use the instructions or statements which are in the language English language. Each statement must be precise and well defined to perform a specific operation. Each statement must be well defined. There should not be ambiguity. Okay, it should be clear or it should be precise. And when these statements are carried out for a given set of conditions, they will produce a required results. So based on the requirement or based on the problem, okay, each and every problem will use the desired or different results. And next we see about the characteristics of an algorithm. See, the basic 5 characteristics of the algorithms are nothing but input, output, definiteness, finiteness, and effectiveness. All these are nothing but characteristics of the algorithm. The first characteristic is input. So here the input is nothing but algorithm can accept 0 inputs or more than 1 inputs. Algorithm must and should accept or it may accept 0 or more than 1 inputs. In output case, it should produce at least one output. In output case, okay, the algorithm should produce at least one output. And the definiteness is nothing but it should clear, it should well defined, and it should be precise. Your algorithm should be clear, your algorithm should be well defined, and your algorithm should be precise. That is the definiteness. When it comes to the finiteness, your algorithm should be computed within the finite steps. Your algorithm should be computed within a finite number of steps, and it should not enter into the infinite loop. Your algorithm should not enter into the infinite loop. And the fifth one is the effectiveness. Okay, so effectiveness is nothing but it should be simple and it should carry out a finite time, and it should give the output for manual inputs. Okay, for manual inputs also it should give the output. That is called effectiveness. And next we discuss about the program. So a program is nothing but set of instructions. Okay, program is nothing but set of instructions written to carry out a particular task. To perform a particular task, okay, these are nothing but program is nothing but it is a group of or set of instructions. And the term computer program, see there are different types of programs out there. Computer programs, software programs, application programs, system software. Okay, and just simple program is also a program that are used to refer either to execute a program or collection of source code for which an executable program is created. And a computer program is a set of instructions, okay, or statements. Computer program is nothing but, so this is the definition. Computer program is nothing but set of instructions or statements to carry out a particular task by the computer CPU. And using set of instructions or statements, the user can develop a program or software which is called programming. Next, a program tells the computer what the system will do. The program tells the computer or the system, okay, what it should do. And specifically, the term software describes an operating system or application. The software describes it is an operating system or application. A computer task takes instructions in the form of computer programs. Okay, we fed the instructions to the computer in the form of programs, and then the computer will carry out a requested or required task. Here the human beings cannot interact directly with the computer using the natural languages. So natural languages which we speak. Okay, these languages are not enough, or these languages are not understandable by the computers. Okay, computers understands only the programming languages. They understand only the programming languages. They will not understand the natural languages. And there are different types of programming languages are there. Nothing but Basics, COBOL, Fortran, Pascal, C, C++, Java, .NET, okay, etc. All these are the different programming languages which are available. Okay, so this is for today class, and thank you.